This review is going to cover multiplication and addition of polynomials, as well as negative exponents, as well as the beginnings of factoring. Here we see binomial times binomial times binomial, and I'm going to begin by multiplying the first two together using the FOIL method. The first term of FOIL, x times x, gives us x squared. O for outer refers to the x on the far left and the 2 on the far right, so plus 2x. I, standing for inner, is the two terms closest together, the 1 times the x, giving us plus x. And L, 1 times 2, is positive 2. Combining these middle terms together, we have x squared plus 3x plus 2. Now I'm going to bring down the x plus 3, which is going to get multiplied by this trinomial which we have out in front. Now, we have basically 6 distributions. X squared needs to be multiplied by each, 3x needs to be multiplied by each at the right, and 2 needs to be multiplied by each at the right. I'm going to do this in a slightly different way because I haven't shown this to you yet. X plus 3 I'm going to bring down right below. I'm going to draw a line and I'm going to multiply this just like we learned how to do regular multiplication of whole numbers. 3 times the 2 above it gives us 6, positive 6. 3 on the bottom right times the 3x in the top center gives us positive 9x. 3 on the bottom right times the x squared on the top left gives us 3x squared. Then we begin multiplication with the x times everything above it. X times the 2 on the top right is 2x, and notice how I'm lining it up beneath the 9x. Then x times the 3x above it gives us 3x squared. And finally, x times the x squared on the top left gives us x to the third plus that 3x squared. Now I'm just going to add down like terms, x to the third plus 6x squared plus 11x plus 6. Okay? That's all there is to that. Problem number 2 here. We see 5 to the third divided by 5 to the negative 8th. We have a couple ways of looking at that. We can either go 3 minus a negative 8, which becomes 3 plus 8, or you can think of this negative exponent moving that 5 to the 8th upstairs, giving you 5 to the third times 5 to the 8th, which is 5 to the 11th. Notice that that is not 25 to the 11th. Had that been x to the third times x to the 8th, you'd have no problem with x to the 11th. Why should the 5 times 5 become something other than the 5, just as the x's stay in x? Okay, this next one here, there's nothing to do inside the parentheses. Personally, when I have a negative exponent outside, I don't like to shower in that negative exponent. I like to just use the negative first. That negative, which goes into everything inside, moves everything to the denominator, giving us 1 over 5x to the third y squared. And then I'm going to raise that all to the second power, giving us 1 over 25x to the sixth y to the fourth, multiplying those exponents at each of those steps. Problem number 4. Again, I'm going to clean up inside my parentheses first. I notice the 4 over 6 can reduce to 2/3. With the x's, that x to the third upstairs comes down to join the x downstairs, and that gives you x to the fourth downstairs in the denominator, and y to the minus fifth moves up to the numerator, giving you y to the sixth upstairs, all to the negative third. Now that the inside of the parentheses is all simplified, rather than showering that negative 3 in, I'm going to just shower in the negative. That moves inside to each term, and basically each part inside moves from numerator to denominator or vice versa. which is going to create 3x to the 4th in the numerator over 2y to the 6th down below. That all is going to get raised to the 3rd power. And then I'm going to actually do the raising to that 3rd power. 3 to the 3rd makes 27. Multiplying exponents, I get x to the 12th. Down below in the denominator, 2 to the 3rd makes 8. And multiplying exponents, I get y to the 18th. And that is the answer, which does not reduce any further.